Hello everyone, my name is James. Welcome to King Spine Woodworking. Today we're going to finish our sleigh bed project. When we finished off last week, we had all of our parts milled and cut to size, and we also had all of our mortises cut. To start with, I'm going to mark out the tenons for the main rails that go on the sides of the bed and hold the headboard and the footboard together. I'm just going to take my time and do an accurate layout of what I want it to look like, and I'm going to take them over to my crosscut sled, and I'm going to put my dado blade in there, and I'm going to cut the tenons on that. If you have a crosscut sled with dado capability, it makes real quick work of a project like this, and if you don't, I do have a video on just how to make one, and I'll put a link to that in the description below. I cut a sample board of this same thickness material first, so that I could kind of sneak up on the exact blade height that I needed to cut to the correct depth for this tenon, so that it fits snugly in the mortise that I have already cut. And I'll just flip it over to cut the other side after cutting the first side, and that will ensure that my tenon is right in the center of the board. A number of years ago, there was a study done on optimal tenon sizes. Popular Woodworking magazine dropped anvils on these joints to test their strengths and failures. Nearly all of the old and very old woodworking textbooks say that you need to have a tenon thickness that is 1/3 of the thickness of your board that the mortise goes into. Well, they actually determined that the optimal strength would be if the tenon ended up being half of the thickness of the stock being mortised as opposed to 1/3. So since that point, I have always made a point to make mine somewhere between 1/3 to 1/2, and generally closer to half. And what that has done here is given me a 1/2 inch thick tenon. For projects like this, it's pretty common to just cut the two faces of the tenon down and show the two structural shoulders. And the edges of the tenon, which would be the top and the bottom portion, we're going to cut those off by hand. So I'm just carefully measuring the amount that I want to cut off so that it fits nicely in the mortise. To cut these down, I like to use the Japanese saws. This is a dozuki saw, which is a tenon saw. Dozuki in Japanese means tenon. It has a stiff back, a straight spine there, so it cuts a nice straight line. It's important to take care when you are approaching the shoulder not to nick the shoulder with the saw. That shoulder is going to be seen from the side, and we want to make sure that stays looking good. And you can also see it's very typical to leave a portion of the tenon still there on the workpiece and to use a chisel to just hand pare that portion of tenon off. That way we can get it down exactly flush with the shoulders, and it'll look like we have one consistent shoulder all the way around the outside. For the next bit here, you have two options. You can square the hole in the mortise, or you can round the tenon to fit the mortise. And that's what I tend to do. I like to round the tenon to fit the mortise. So I use a rasp and I use a chisel to fine tune it, and I adjust the fit back and forth a couple of times until I get it just right. With those cut, I am going to jump back on the leg for just a moment because I have to send a bolt through the leg into the rail in order to secure this bed together. We can't glue the tenon in because otherwise you would not be able to disassemble the bed and reassemble it later, and it certainly isn't going to get through a house like that, so we need to have bed bolts to put the thing together. I have used a doweling jig here on the back of this leg in order to get a perfectly straight line going through the center of the leg. And here I started the hole with my brad point bit, and halfway through I had to switch to a 12-inch drill bit in order to get all the way through. So here's the leg. That is the line that indicates where the bolt is going, and there's the hole all the way through where we're going to put the bolt to hold it together. This bolt and barrel nut kit came from Benchcrafted. It's actually designed to hold real heavy workbenches together. It's a 1/2 inch thick steel bolt, 8 inches long, and that's a solid steel 1 inch diameter barrel nut. I've marked the depth that I need to go to with some blue tape on my drill bit, and I'm going to use the hole that already exists in the leg as kind of a guide in order to keep the hole going straight all the way into the rail itself. And those wood chips are coming up through the mortise. This is a mortise that is going to hold the rail that goes between the two legs on the headboard together, and this bolt hole does go through them, and just a little bit right at the edge, and I'll show you how we deal with that when we get to assembly of the headboard and footboard portions. Next, I'm going to take an accurate layout of where exactly I need to insert this barrel nut. And we don't have to be extremely accurate. If we're off by a 32nd or even a 16th, it really won't make a difference. It'll still work just fine. And I'll just put my hole through here with a 1 inch Forstner bit. I do need to be careful going down for the depth. I don't want to shoot all the way through this through the rail. And I can feel quite a bit of jumping as I push down through the hole that I bored through a minute ago. At this point, I have taken the leg back off, and I'm just going to keep going real slowly through there and checking the depth of the barrel nut there and making sure that I get it to just the right depth for the bolt to thread comfortably in. Once that's done, I want to go back to the outside part of the leg, and I want to cut in a recess with my Forstner bit to bury the bolt head. But I have a 1/2 inch hole there, and the only way to use a Forstner bit is to have solid wood. So what I've done is I've just put a little 1/2 inch dowel in there, glued it in, sanded that flush, and then I'm going to take a moment to remark it out, get it laid out just right. I'll find my center point, and now I have solid wood to use my Forstner bit to drill a hole that's the size of the bolt head so that I can get that countersunk a little bit below the surface. Since I'm not using a drill press and I'm drilling this by hand with a Forstner bit, if that hole were still there, then me drilling this portion would just make a big mess. And now I can just take the bolt itself, push it back through the hole, and knock the little tiny piece of the plug that was left out of there. And with all the dust cleared, we can put it back together and test it. So you might be wondering why so much of the barrel nut is sticking out. It's because it's a great big barrel nut. It's actually designed to hold big heavy workbenches together. I could have used a grinder and maybe cut it short, but it's really not going to be a problem because I'm going to run a cleat along this rail all the way down, and that's going to hold the box spring of the mattress, and that cleat is going to pretty much come out to about the same distance as that barrel nut comes out, so it's not going to be really noticeable at all. So I'm just going to file the sharp edges off of this so we don't get any chips or splinters later. Maybe put a little bit of a bevel on it so it'll go in and out easier for our assembly process later. And then I'm going to take the time to carefully mark it. So I'm using a permanent marker, and I'm going to mark the tenon and the mortise for each of the four so that I know what goes together in the end. After completing the side rails for both sides of the bed, I am now going to work on the headboard and footboard rails. This rail here is going to be permanently glued into the headboard, holding the headboard together, and I'm going to cut the identical one to hold the footboard together, and the headboard and footboard will stay together as units. And I'll just use the same procedure here that I did on the side rails to get my tenon down to the exact size. And once I've got it to shape, I'll do a little test fit and make sure it fits nicely in the mortise. And if it doesn't, we can just make some adjustments and fine-tune it until it does. So next I put a little jig together so that I can cut tenons on the end of these rounds. I just cut a couple of 2x2 boards at 45 degrees that kind of held this big dowel here in place. And I put a little sacrificial board against my fence on my table saw. And I'll just kind of move this thing forward into place with the dado blade going. And I'll raise the dado blade a little bit, and I'll start cutting my tenon. I'll raise the dado blade a little bit more and keep cutting my tenon, and we'll keep going like that until I get the tenon down to the exact diameter that I'm looking for. And it actually cut really fast. I think it took me 15 or 20 minutes to put the jig together, but probably only 2 or 3 minutes to cut each tenon down. And you can see I've got the jig weighed down with some weights as well as clamped down. That way it's all nice and snug and I didn't get any movement out of it. And we'll do a little test fit to see how it goes together. For the next step, I have to dado a groove all the way down this cylinder. There's probably a few ways to do it. One way is I considered putting the groove in before I turned the cylinder round, but I was worried about it ending up in exactly the right place. So I thought I'd go ahead and make it round first and then mark it and do it, and you can see how I've done that here. Another thing that I've done is I have printed a copy of the edge of the profile of what this looks like from the program, and if anybody were to get the plans, it'll be included. This piece will be included with it, so you'll know exactly how to line this up and cut the dado. And then I'm just using a straight edge and holding my cylinder straight in order to transfer this line straight all the way down the cylinder. As soon as I have those two marks done, I'm going to take my little paper template and I'm going to check it on the other side and draw those lines down and make sure everything does line up just right. And I'll sketch that out and I'll put this together to cut the dado on the table saw. What I'm using here is double-sided tape. It's got a little foam pad between the two sides of adhesion, and it's a real powerful tape. I think it's a 30-pound per square inch tape or something like that. And I'm going to hold my cylinder so that my dado is square to the table surface, and then I'm going to slide that 2x4, which is flat on one side. I've actually jointed both edges flat. I'm going to hold that flat on the table, slide it up to my cylinder so that the tape sticks. And I'm going to do that on both sides. So we're making sure the cylinder's in the correct orientation with respect to that dado, so we're straight up and down. And this is all we have to do to hold this thing together in order to cut our dado groove in it. And I'm using these clamps to squeeze real hard over the tape in 5 or 6 different spots to kind of make sure that it has adhered really well. And all I really did after that was take it over to the table saw, and I just eyeballed it. I lined it up so that it looked as if the dado were going to cut right down the center of that. I made the dado stack exactly the right width on the test piece. And you can see here as the dado exits this side, it was actually a pretty good alignment. And it was surprisingly difficult to get the taped boards off of our cylinder after that. Okay, so now we need to cut the plywood panel that's going to make up the main body of the center of our headboard and our footboard. Once it's cut to width, I like to use a straight edge and some tape in order to make sure I get a nice clean square cut. And then I do have to cut a small dado into the end of this on both sides, and so that it will fit into the mortise on the headboard leg. Now we're just taking off 1/8 inch per side. We have some 3/4 inch plywood, and I've got to fit this into a 1/2 inch dado. Once again, we need to notch the very edge of our tenon here in order to get it to fit perfectly within our mortise. So you've probably noticed that I am rounding over the edges of all these tenons. Alternatively, you could simply use your chisels and you could square your mortises. So sometimes I do round tenons to fit the end of the mortises. Sometimes I square up the edges of the mortises and I leave the tenons square. So it's really entirely up to you. Next, I think I'm going to put a 1/8 inch radius roundover all the way around the legs in order to kind of knock off those sharp edges. And we'll do the same for the rails. So before we assemble the headboard or the footboard, I'm going to put some biscuits into the rail and into the plywood in order to hold those securely together. We know in the top there is a dado all along the length of the round dowel, holding it to that point securely, and this is going to hold the plywood down to the rail securely. So now the plywood will be connected and attached within the footboard on all four sides. When installing biscuits, I like to make sure that I thoroughly soak the biscuits in glue on both sides before I put them into the pocket, maybe even put a little glue in the pocket, because the biscuits need the moisture from the glue in order to work properly. They're made of beech wood that has been highly compressed, and so they're much smaller than they'll be after they soak the moisture in from the glue and expand and swell. They'll actually expand and swell to the point where they form a bit of a mechanical bond, as well as just being placeholders there. But that will only work if you get enough glue all the way around the biscuits. Now that the plywood has been attached to the rail, we are putting glue on the tenons in order to assemble it to the leg. And of course, I do like to put glue on both sides, so I'll put glue in the mortises as well as on those tenons. For big glue ups like this, you definitely need to have more than one person. If you work in a shop by yourself, you can really make life easy if you get one or two people out there to just give you a little hand whenever you're doing a great big glue up. And now we're preparing to put the dowel in place on the plywood as well. So we're going to make sure we get glue all along that dado. After you master the advanced Kung Fu glue technique that I taught in the crosscut sled video, you are ready to move on into training on glue weaponry, the most formidable of which is the glue sword. This is the best way to clean the glue out of corners. When we put the plywood panel in for the headboard, that encroached just a little bit into the hole where the bolt goes. So I'll just take my drill and clear it back out again. And same thing on the other side. And finally, it's time to go ahead and do a test assembly and see how everything looks together. So we've made sure that the A mark on the tenon goes with the A part in the mortise and so on to ensure that we're putting it back together the correct way. So when putting these together, it's not too complicated. It's nice that the barrel nut sticks out so far in this case here. You put the barrel nut in, and then we'll slide the bolt into the hole on the other side. And then you can kind of fiddle with the barrel nut, twist it back and forth until the bolt catches. And that's all there is to putting it all together. Now once it is together and bolted down securely, I'm going to go ahead and take my low angle jack plane and kind of flush up all of these surfaces. We'll do the bulk of the work with the plane, and then we're going to switch over to the sander after that. The secret to making these things go fast, especially when you're dealing with end grain up here like on this oak, which is such a hard wood, is to start with a real aggressive grit. I'll start with 60 or sometimes even 40. That goes a long ways to shaping this down really fast. And once I have the shape the way I want it, then we'll just transition up in grits. And we make all sorts of small sanding blocks. We just cut a little piece of wood at an angle and glued a small strip of sandpaper on it to sand areas that are ordinarily very difficult to get to. After I get up through the grits, I get down to probably about 320. We're going to put an oil finish on this, and I like to do the final sanding by hand so I can kind of feel and make sure there are no rough spots. With the sanding complete, I'm going to move over and cut the cleats. These cleats are boards that I'm going to attach to the rails in the inside all the way around, and they're going to support the box spring. Once that's complete, I'm going to have to make some holes for some clearance space for those barrel nuts. The bed was designed so that the location of the barrel nuts, the top of them, coincides with the top of this cleat, which will hold the box spring. Once these are done, I am going to affix the two cleats together with a little bit of double-sided tape here so that I can put some dados in them. And I want the dados in each of them to be at the exact same location. So I'll end up sticking them together here, and I'll cut the dados together. So I've got the dado blade set up in my crosscut sled with the dado plate in. And I've got the rough location marked where I want it to be. And I've taken measurements, and now I'm cutting them both, and I'll cut them at the same time through both of the cleats. And so you might notice coming up here that my line is right at the edge of the slot in the crosscut sled. This is how I'm going to align the cut. With the cleat that goes in there, it's comes right up to the exact edge of the blade, and so I can just line up both sides to the edge of that slot, and my location will be exactly where I want it. And I'm going to take my router with the 1/8 inch radius roundover bit again and kind of ease all of the edges here. After that, it's time to apply some glue and attach it to the rail. So I've set this up with a little spacer attached to it because I want the cleat to be about 3/16 above the bottom of the rail, and that spacer is just giving me the correct alignment. And now you're probably wondering why I am screwing this together. In truth, I imagine the glue is far more than what's needed to hold this securely in place. However, I'm going to feel a little bit more comfortable, especially since this is going to a client, if I put some mechanical fasteners in as well. So I've measured about every 8 or 10 inches here, and I'm going to go ahead and put a screw in, and that'll just give us a little bit of extra reassurance. And so we don't have to see those unsightly screw heads. I have countersunk them down a little bit below the surface. And Cy here is cutting some plugs for me to fill into those spots. So I just put a little bit of glue on the plug itself and then tap the plug lightly down into place. One thing I do try to make sure of is that the grain on the plug is running the same way as the grain on the board that it's going into. That way the plug tends to disappear after we sand them all together, make them flush. It's not so obvious. If the grain were going opposite of the way the grain is running in the piece, then it's a little easier to see the plug afterward. And after cutting it off, I sand it all down flush. And while you can see them a little bit, they're not that much of an eyesore, and they're going to be underneath the box spring, underneath the bed, so no one's really going to see them anyhow. For the next step, I'm going to go ahead and cut the slats that are going to fit in those dados. And we've got some sleeping shop dogs over there in the corner. They don't seem to mind the noise of the table saw at all. Okay, after the slats are done, I am going to jump back over and put the cleat on the headboard rail. This is the same exact cleat that I put on the two side rails a few minutes ago. I'm just going to put one on the headboard and the footboard rail as well, and that will help hold the box spring in place. I've used the same spacer, and the cleat is the exact same width, so they're going to be at the same altitude, essentially. So after gluing and clamping them into place, I'm going to go ahead and do some pre-drilling and put some screws in also. You just never know. They may decide to park their car on the bed later. We just want to make sure that this holds up. And it's important to get the biggest mallet that you have to put these plugs in with. Now that everything has been fully built and assembled, we are going to do some final detail hand sanding before our last assembly and finishing. Our client has decided that they would like to have an oil finish on the bed, and so that's what we're going to do. We're going to do 3 or 4 coats of this oil finish, let as much soak in as will each time, and then we're going to buff the excess off of it. Whenever we do an oil finish, we usually like to sand it just a little bit finer than we would with, say, a polyurethane or a lacquer finish, because there isn't really a film that resides on top in the same way that it does with a polyurethane. But we sand it probably between 220 and 320. We don't want to go any finer than 320 because we need some of the pores open in order to absorb the oil. But we don't want it any rougher than 220 because the texture will be able to be felt through the oil. So 220 to 320 is kind of the ideal range. A great oil finish to use on a project like this would be Watco Danish oil. It's a hardening oil and it really brings out the character of the wood. We'll put a link to that in the description. So these cross slats that we have cut to put in here are really sort of an optional step. They give a little bit more firmness to the bed, but they're not really necessary. If you've ever seen a regular bed frame, the bed is really just sort of held around the perimeter. But I put these in here if the client wants it a little bit stiffer. They can use these. If not, they can take 1 or 2 or all of them out till they get the exact amount of spring that they would like to have in their bed. And there we have it. Our project is complete. The queen-size sleigh bed made all from oak. Thanks for watching.